Functions are an important part of programming, so there is a lot to cover this time. Pay attention to the vocabulary of functions. Understanding the vocabulary is important so that you can clearly discuss functions with other programmers. Functions allow us to pull functionality into separate areas of the program, so we don't have a big, cluttered mess in main. And because functions have names, they also allow us to keep our program clean by describing what the code inside of a function does. So, what is a function? In math, we use functions a lot. X is a variable we plug into the function f of x, and we get some output, which is usually a y-coordinate. Functions in C++ look similar to in math, except that we need to specify data types for the return value of the function and for the parameters. So here we have the data type of the returned value, or the output of the function name, the parameter data type in name, and the function body. Our main is a function. Notice that we specify its return type, which is an integer, and at the end of the program we return 0 to close the program. When we write a function, we will specify the output, which is what kind of information will be returned from the function. It could be an integer, a float, a boolean, or nothing. The input, or what kind of information needs to be passed to the function in order for the function to work with it. And we'll have a function name, which we'll use to call it from other places in the program. So for example, we could write a function called slope, which takes in two coordinate pairs, or basically four variables, x1, x2, y1, and y2, and then it outputs the actual slope between those 2 points. So far, we've been writing all of our code within main. If we want to calculate slope more than once, we have to keep retyping the formula. The more you write duplicate code, the higher chances of causing errors, such as when making changes to the formula in one place, forgetting to change it in the other spots, or accidentally making a typo in one of the areas, resulting in a logic error. We can write a function to do our calculation for us, and then we simply need to call the slope function anytime we need to calculate it. This also keeps our code cleaner because we have a function name that describes what this formula does, and during the main part of the program, we can also say, okay, now we're calculating slope. You may have already used some functions that are part of the C++ standard library, such as the random number generator, rand. It takes no input, but it will return an integer value output. Or square root. It takes some sort of input of type double, and it will return a double, which is the square root of the value passed in. You can look up these functions on the C++.com reference website. It will tell you the input, output, and sample code, and you might find some useful functions for different types of libraries. So let's talk about the parts of a function. A function declaration is simply telling C++ that there will be a function with some name and parameters, but the function declaration does not contain the internal code. It is similar to a variable declaration because it ends with a semicolon. However, it still contains parentheses and a list of parameters. A function definition is where we actually add code to the inside of our function. The function body is contained within a pair of curly braces, and does not have a semicolon at the end of the function header. Here you can see the function declaration for a couple of functions, and the function definition for one function. The line that specifies the function return type, function name, and function parameters is called the function header. The variables listed within the parentheses of a function declaration or a function definition are called parameters. Here, a, b, and c are parameters. A function isn't required to have parameters. If the function doesn't need any input, the parentheses are left empty. The function body is the code contained within the curly braces. This is the code that will be executed anytime the function is called. A function is called whenever we use its name within the program and pass arguments to the function. We can store the return value of our function in a variable. Here, the function calculates one of the x solutions of the quadratic formula, and we are storing it in a variable called x1 back in main. In our main, we have declared a, b, and c as variables. We pass the values of a, b, and c into our quadratic x1 function as the input, and we get the output based on the quadratic formula. When we are calling a function, the variables we pass into the function are called arguments. When we're writing our function definition, the input values that the function is expecting are called parameters. Arguments and parameters seem very similar, but remember that they're different. The argument is when we're calling the function, and the parameter is when we are creating our function. The arguments are the variables, or the values that exist outside of the function, that are being passed into the function. The parameters are a way to specify what kind of input the function is expecting. Additionally, the names of the variables passed in as arguments do not need to match the names of the parameters. Any data type that we use for variables, we can also use as a return type for our functions. So here we have integer, float, boolean, and string as return types. If we want to create a function that does not return anything, we use the return type of void. Then, no return statement is required. For example, we could store our main menu within a void function, and then display it each time through the program. Or we could just use it to format some information before we display it to the user. That was a lot to cover, but we're not done yet. Let's review by doing some programming before we continue. Okay, let's start with something we've done before. Let's just make a program that will calculate C for the Pythagorean theorem. So, first we need A and B, and we'll declare C. So, ask the user, what is A? A, what is B? B, and then we will calculate it. So, C squared, so let's say C squared is equal to A times A plus B times B, and then C would be equal to the square root of C squared. So C squared is C squared, and C is C. So we run it. Oh, it's running the wrong program. Just a moment. Activate. 2, 3. So it's 4 plus 9. Okay. So if we were to make a function to calculate C, then we would say, well, it's going to return C. C could be a number with a float, a variable, because, or I mean, sorry, a fraction, because, you know, you could do square root of 4 and that's 2, but if you did square root of 3, that's going to give you a number with some sort of remainder at the end. So float, we know we want to turn that, get that. Let's say, let's call it Pythagorean for now. And its input will be both A and B, which are required to calculate what C is. So this is the function return type, this is the function name, and these are the two parameters. And this whole thing is the function declaration. So the declaration has the semicolon at the end, and it does not have the function body. You could go ahead and put the function definition up here. That would be fine. It's just a little bit messy when you're putting everything in one file. So usually if I'm putting my functions in the same file as my main function, I will put the declaration up top, and I'll put the function definition at the bottom. So really I can copy paste this part and start it here. So this, or this part with the return type, the name, and the parameters is known as the function header. And then inside of these curly braces is the function body. So this is where we do all of our math. So we can basically move this stuff in here and then return C, since we're trying to calculate C specifically. And we can even say C is, and we can call, usually this would pop up as a hint. We'll pass in A and B. So this is a function call, We can call it within our cout, like if we just only wanted to output the result, or if we wanted to store it, we could also use it in an assignment statement. So either way this works. We can output it, we can store it. So I could put C here as well. Now if I run it, I have some sort of error message, so let's see what that says. Redeclaration, so I already declared it up here. Let's go ahead and just do that. And we didn't declare it down here. What is A, 2, 3? So now, these two right here are called arguments, while these two here are called parameters. And these can have different names, so we can change this to number 1, number 2. These don't necessarily need to match. Remember that the parameters are specifying what will be used inside of the function. What is the input? So these are kind of like variable declarations that will be used internally, but the values of these get assigned when we pass in arguments. So arguments are either numbers or variables that already exist. We could hard code these, or we could just pass in variables, and these are the values. So at this point we have arguments, at this point we have parameters. And then we get our result and that. So this might not be very obvious as to why it might be useful to use functions in this context, but as a program starts growing, it helps keep things cleaner. Like if we needed to call this multiple times, we don't want to write the same formula over and over again because that can give us some errors. This also kind of gives us a description of what's going on here. Like if you weren't familiar with this, what this formula was, this could kind of describe it. Like maybe this would be get hypotenuse, however it's spelled. I don't know. It's get the length, or whatever. So let's keep it as Pythagorean. So that's a simple example. Now let's go into something a little bit more advanced. Okay, so let's start by writing a simple shopping cart app. So of course we always use IOStream, and we have our int main, and we're just going to keep looping the program until the user decides to quit or quote unquote check out. So while not done, and then so we'll start off without any functions and go back and clean it up in a bit so we can kind of see the difference. So every time we start the shopping cart, or we should start the main menu, we say like, let's have item 1, it can be, I don't know, I'll just think of food, bagel for $5, it's an expensive bagel, coffee for $6, I don't know, cookie for $2. So I'm writing this out every time through the loop. Then we say choice, what does the user want? What do you want? And we'll get their input. And up here we'll have a balance for how much they have in their shopping cart. So if, well, let's say while choice is not 1, and choice is not 2, and choice is not 3, then we're going to tell them invalid choice. Try again. So that will keep looping while they are inputting something that's not on the menu. Also, let's say number 4 is checkout. So, and choice is not equal to 4. So once they choose something valid, if choice is 4, we're going to basically say done is true, and at the end of the program we'll say your total is, and we'll put the balance amount. So if we run this, we can just say check out, well, your total is $0. Otherwise they're adding something to the cart. Now we can do if choice is 1, balance is plus $5, else if choice is 2, balance is plus 6, and else if choice is 3, balance is plus $2. So we can run this, 2, 1, 2, and then check out. So $24. So this program is a little long. It's not too unmanageable at this point, but we could clean it up a little bit. So let's start by saying display item, and I'm going to add string to our program so we can pass in the name. So you can say string item name and a price. And we might even want to put what line number. So we'll start with number, the period, the item name, and then maybe a tab and a $sign and the price. So maybe that's not saving us a whole lot of lines of code, but it's a little bit easier on us where we can just say display item, it's item 1, it's a bagel, and it's $5. 2, 3, coffee, cookie, 6, and 2. So that will auto format it for us, so we don't have to worry about getting it perfect every time we type it out. It'll handle that output for us. But then we have this other option. Oops. So we can say void display option. There's another way we could do this, but we haven't gone over it yet, so let's just say item name. And we can replace this and say number, item name, and we'll replace checkout here. And it doesn't have a price. Now, maybe I'll just go ahead and show you. I can name this also display item and reuse that function name, but it doesn't have the price at the end, and that's okay. It's just reusing the same name, but it has a different number of parameters, so it'll work fine. Okay, so that's one thing. Well, we can also kind of shorten this. We'll have the user choose a choice. So maybe you want to say int get choice, and maybe we want to specify what's valid and invalid. So let's say int minimum, int maximum. So we can say they have to choose between 1 and 4. We're assuming that we'll never have like a random other number outside of that range. So we'll put like a little prompt arrow. We'll get their choice. So we'll say get choice, and we'll say while choice is either less than the minimum or choice is greater than the maximum, we'll just tell them invalid option, try again. Actually, we can change this up where we set this to a do while loop, and instead of automatically assuming it's incorrect, we get the option at least once, and if this is true, it'll at least display the error message. But it'll keep looping until it'll reuse this part, and it will keep looping. So get the choice. If the choice is less than minimum or greater than the maximum, then say invalid, choose again, and we'll keep looping while that's invalid. So once we're outside of this do while loop, that means they finally entered a valid option. So now we can erase this and this check right here. We can say int choice equals, and we have our get choice. Our minimum is 1, our maximum is 4. And now we can keep reusing this menu. So for instance, if they wanted to quit, you can say, are you sure you want to quit? and then give them the options 1, yes, 2, no. But again, we have these out here. We can say display item. 1 is yes. 1, yes. Display item 2, no. And then we'll say int choice is get choice with the minimum and maximum. And if choice is equal to 1 for yes, we will then set the done flag to true. So this is just allowing us to kind of easily reuse some of our input-output. I'm getting an error here. What is it saying? We'll close that. Build messages while expected before. Oh, I forgot the while part. Now we can run it. Oh, I have another error down here. What am I missing? I have a random L out at the end. Run. Okay. Int choice, and I used double equals on accident. Okay, so now we can say, well, check out. Are you sure you want to quit? Yes or no? No, and goes back. Now, I'm just going to add an extra end line here just because I feel like it makes it a little bit cleaner. It'll not really bleed into the rest of the menu. Okay, so we have display item and display our menus. So down here we have choices for different options. So let's say instead float add well, let's see, we want to say if choice is 1, 2, or 3. We could make a function that handles that, or we could make a function that adds to the balance. So let's, for now, this isn't the best program in the world because we don't have all the options we could say, but add price of, and let's say we have a string food name. So then we say if food name is bagel, we're going to return the price of the bagel, which is 5. So get price of might be a better name. Else if food name is coffee, we can return 6. Else if food name is cookie, return 7. Now, oh, sorry, this is set number 2, the value of 2. So, you know, we could also say like $5.99 or $6.45 or whatever. Now, if they don't choose if they pass in a food name that we don't have, let's just return 0 as a default, just so we are returning something. It's expecting us to return a float. So now we can say if choice is 1, we're going to add the price of a bagel. Here, if choice is 2, we're going to add price of coffee and cookie. But we can also replace this up here. So we can use a function call within another function call, because this is going to return a float. So kind of think of it as it's returning a variable, more or less. It's returning some sort of value, and that value can be passed into another function. So now we can run this, and we don't have to worry about keeping the correct price in every area that we use it. We can just keep reusing it over and over. We check out. Yes, we want to check out. We have some value. And even we can have something like float add tax. So let's put in the balance and tax rate. So we can return balance plus balance times tax rate. So at the bottom, your total is that, and then let's say float with tax is equal to our function balance, and then I don't know what the tax rate is, so just add something in there. With tax, it is with tax amount. So bagel, coffee, cookie, blah blah blah. Are you sure you want to quit? Well, maybe I should say, are you sure you want to check out? So your total is $28.90, and with tax it's $31.79. So let me change this to, are you done shopping or whatever, ordering. Are we done ordering? Yes. We can even, at the end of our menu, display our current total, our running total, so current total and our balance. And so that's an example of how we could substitute our functions here, just to make things a little bit cleaner and easier. Now we could even kind of just take each of these options and make them their own function. You can continue abstracting this as much as you want, but this is just a simple sample to kind of get you used to that. Okay, let's talk about scope before we continue with functions. Scope refers to where a variable or function is available within a program. A variable declared within a block of code is only accessible within that block. Think of a block of code as being within the curly braces, such as within an if statement, a loop, or a function body. In this example, B only exists within this if statement. Outside of the if statement, it does not exist and cannot be used, though a different variable with the same name could be declared. Variable names can be reused if the scope is different for both. Number A and number B here are within the scope of addNumbers function, and then number A and number B below are within the scope of the main function. Between each, they are different variables, they just have the same name. A variable that is within the scope of some code block is known as a local variable. These variables are only accessible from within this scope. So here, tax is a local variable of the addTax function. Here, we've declared tax twice in two different scopes. So one is local to the if statement, and one is local to the else statement. And neither of them are in scope inside of the main function as a whole, or outside of this if-else statement. If we try to use a local variable outside of its scope, we will get a build error, or a compile time error, because the variable does not exist. A global variable is declared outside of all functions, including the main function. A global variable is accessible to all code below it. However, using global variables is considered to be bad practice, and you should avoid them. They can lead to hard-to-follow code, hard-to-maintain code, and just kind of making a mess in general. If you want a variable to be accessible between different functions, you should be passing the variable as an argument. So here's an example where we're using a global variable to define the tax rate, and we're using it in a function below. And this is bad practice. Instead, we should be declaring tax rate somewhere within a function, like main, and then passing it to whatever other functions need it. Okay, now that we've covered some scope stuff, let's talk about passing parameters some more. When we pass a variable to a function, a copy is made by default. Any changes made within this function to that variable do not get saved once the variable leaves the function, because it's a copy, not the original. This is called passing by value. We are passing the value of a variable to the function so that the function can work with it. When the program returns from the function, either by return statement or from reaching the end of the function, the variable will still have its original value back in main, or wherever it's called from. We may want a variable to change within a function, or we may want to return multiple values from the function. In C++, we can only use the return keyword to return one value. But there is another way we can return information from a function. If we want to pass our arguments by reference, within our function header we need to specify those parameters with an ampersand after the data type. That's the only thing that changes when passing by reference here. We'll still use the number variable the same way we do within the function body, and we'll still call the function in the same way. But now the variable that we pass into the function during the function call gets updated. Okay, so let's do a short program to see this in action. In this program, we have our quadratic formula, but we had to create two different functions to return the plus and the minus version of the x answer. So what if you wanted to just have one function Well, we can't return two different values. I mean, we can calculate it within the function like this. So float x1 is equal to this, and float x2 is equal to that. But we can't return two values via this return statement. You can't say x1, x2, that's not going to work. So let me erase this for now. I'm going to erase quadratic x2, and we're just going to make it quadratic. So in some way we want to return both values, both x1 and x2. So we have to do this by passing it by reference. So these values, a, b, and c, they're copied here. Even if we changed a, b, and c within this function, they would still be the same. So let's temporarily say return x1 just because it's expecting an x1 to be returned. But let's say cout a, b, and c, and we'll do it before and after this function just to check. So say we enter some values, I'm going to just change a, b, and c to 0, and when I run the program, well, it's expecting an a, b, c, so I'm going to say 2, 3, and 5, and before and after the function, a, b, and c are still these original values. They don't get changed to 0. They're changed to 0 within here, and I could move this here. So we could say 2, 3, 5. So first time it prints, it says the right correct values. The second time it's in the function, and they're set to 0. But once we return back to main, they're back to their original values. These are passed by value. Almost everything in C++ is passed by a value as a default. But what we're going to do is we're going to use pass by reference in order to get multiple values back. So I'm going to create a by reference value for x1, or sorry, yeah, by reference, and x2, and we'll put it in here as well. And then instead of returning a value, we're going to say void, because it's not using the return keyword anymore. So now we're going to have to declare our answers beforehand, before we call the function, and we're going to have to pass them into the function as well. So these two will have different values once they're returned. As an example, let's initialize these to 0, just so we have something to look at. And before, x1 is x1, x2 is x2, and we'll look at it after. Okay. So now I'm going to remove these two declarations here because we have parameters named x1 and x2. We don't need to create local variables here. These can just be used like a normal variable. We just have this ampersand sign in our parameter list. Also, they're called the same way as other variables. It's just this part right here that's a little different. So x1, x2, we assign these values. We don't have to do anything else. We don't have to return. We've made it a void, so it's not expecting any return values. And then after the program calls the function, it should have our x1 and x2 values. So let's say we have 1 and 8 and 15. So before x is 0 and 0, but in the function x1 and x2 change, and now they're -3 and -5, which is the correct answer. So if we wanted to clean this up a little bit, we could say enter a value for a, b, and c. After they enter it, we could say a x squared plus b x plus c. We don't need to output this now, and we can tell the user answer x1 is this and x2 is that. So 1, 4, and 4. So for this function, the x answers are -2 for both. So that's how we would return multiple values from a function. So we just completely ignore the return statement. We don't need that here. We use pass by reference variables instead. So remember the terms pass by value and pass by reference. They're pretty important. Alright, I'm sorry this lecture has gone on so long, but this is all very important stuff, so let's cover a couple more things and then we'll be done. Function overloading. In C++, we can reuse function names. This is called function overloading. As long as the parameter lists between both functions are different, using the same function name is valid. C++ won't look at the return type to tell these functions apart, so these don't matter on whether they're same or different. A function signature is essentially the part of the function header that C++ uses to tell functions apart, the name and the parameter list. You can have as many overloaded functions as you wish. You can make two functions unique if they have a different amount of parameters, or if the parameters are of different data types, or if the parameters are in a different order. C++ doesn't care about the names of the parameters. If the parameters all have the same data type, then it won't be a valid overloaded function. And now for another example. So say that we want to create a function that can add a couple things together. So we'll say add, and we'll have number 1 and number 2, and we'll return its result. Now this is pretty simple, but bear with me, it could be something more complex. So we have some values, and we can create them in main, then get a result by calling add and outputting the result. But what if we had some floats? And of course you can treat floats like integers, so this could all just be floats here, and it would work fine, but just for the sake of showing an example, let's say we have specialized add functions. So we have 2.3 and 2.4, and sure, we can go ahead and run this, but it's not going to give us quite the right answer, because when these are passed in, these floats will turn into integers. So 2.3 will turn into just 2, 3.4 will become just 3. So this causes a problem. Our add function doesn't work for floats. But we can overload the function, and that means we use the same function name. We just differentiate them by what kind of parameters they use. So now we can do this, and it will add it properly. Now when you're overloading functions, the main thing to remember is the parameters have to be different in some way. They have to be unique. The return type doesn't matter. C++ won't be able to tell the difference between int add and string add if their parameters are exactly the same here. But if these have different data types, and then we come down here and we have some integers, the way C++ knows which one to call is based on the data types of your arguments. So here it knows just to call the integer version, and here it knows to call the float version. Now, something else we could do if we had one float and one int, so let's just create a dummy function. We have an int and something with a decimal. And this is going to output integer, and then our decimal, let's say void. Now we could have another dummy and have them in a different order, and that's fine. This will work. It's just they can have the same amount of parameters, they can have the same data types but in different orders. They just need to have unique function signatures. So the signature of a function is basically the header, mainly taking into account the parameters. Finally, default parameters. A default parameter is used to set a default value for a function parameter. For example, we could use overloaded functions to display a record to a user differently, based on what information is available. But this might get unruly if we want different ways to display records for any amount of data provided. So here we have first name, last name, age, and location. We could have a version for when all three are present, or when location's missing, or when location and age are missing, or when location, age, and last name are missing, and so on. Instead of overloading this display record function, we could reuse the same code and simply set some default values. Here we specify the default value by setting the parameter equal to something. So, 0 is the default for age, and undefined is the default for location. The default parameters must go towards the end of the parameter list. There cannot be any not default parameters that appear after default parameters. Okay, and now an example of default parameters. Now for default arguments, let's, for example, maybe have a function called display grade, and we set a, let's say like GPA, and then we'll have string first name and string last name. So then the user can easily output a nice last name, first name, and then the GPA. So here we can say display. We have 4.0 for Guybrush Threepwood. And some other values. And when we run it, it'll display it kind of nicely. There's a tab character, but they're kind of misaligned because some names are longer than others. But let's say we maybe had some students who, I don't know, like just for the example here, let's say they might not have a last name, or might not have a first name, or maybe these are just people who are going to be entered in anonymously. Well, we could have an overloaded function where we kind of handle this, where they only enter one, and then we kind of just say like anonymous, and then the GPA. So that would be a way to overload it. But another thing we can do is to create default values. So if we say equal to empty string, or maybe unset and unset, if the user does not pass in these two strings here, then they'll be defaulted to this unset. Unset 1, unset 2, whatever. And if we run this, we'll see 3.2 is unset, unset. So that would be one way to keep using the same code without having to write another function to handle that. I will note that any default parameters must go towards the end of your list. Like, I don't think you can put something here, like say code, and not have a default for that. It'll really not like that. So keep your parameters that have a default towards the end, keep the other stuff towards the beginning, and this is just a way you can kind of handle if, you know, you don't need some information per se, or maybe they don't have a GPA and they just started. We can even just say display grade. So that might be useful later in the future. It's not quite obvious right now, but that is how a default parameter works.